Today we are going to be jumping into a new unit that is going to be all about factoring. So we are going to be spending a significant amount of time living in the world of factoring. So the first thing I want you to understand is that for factoring, we are basically undoing everything that we did last unit. So you're going to sort of see we're going in reverse order of what we were just working on with polynomials. We have a little bit of review I want to look at. So the first type of factoring that we are going to talk about is prime factoring. And I'm hoping for the majority of us, this is just a simple review, even though you might not remember it right now, right? Remember, prime numbers are numbers that only have a multiple of 1 in itself. You can't divide anything else into it. So when we are prime factoring, we want to split a number down as much as we can. And for most of my students, they remember this as like the tree thing, where if I want to prime factor 60, I'm going to take 60 and I'm going to split it into numbers that will multiply up to 60. You can pick any two numbers you want to start with as long as they are mathematically correct and will multiply to 60. So for example, 60 will split into 2 and 30. You could have picked 6 and 10. You could pick 3 and 20, as long as you're picking ones that match. Then you'll say, okay, can I split 2 down any further, right? No, 2 only has multiples of 1 in itself, so 2 is a prime number, so I'm not going to split that up. Okay, then I'll split up 30. 30 splits into 3 and 10. I can't split up 3 any further. 10 splits into 2 and 5. Okay, I can't split any of those any further, so I'm done. And then every single number that does not have a branch coming off of it, right? So 2, 3, 2, and 5 are the pieces that make up our prime factorization. So I'm going to write these in numerical order. It's going to be helpful later. So I'll say 2 times 2 times 3 times 5 is my prime factorization of 60. Okay, let's say we wanted to prime factor negative 20x to the third, right? So now we have a monomial. What if we want to prime factor a monomial? Well, the first thing to know is that there are no negative prime numbers, really, except negative 1. We can pull that out. Okay, so I always say pull out that negative 1 first, right? Because we don't want to pull out anything else and follow that negative all the way through. Okay, and then we'll split up 20. So 2 and 10, 2 and 5. Okay, so now we're at negative 1 times 2 times 2 times 5. Right? Don't leave this as like a negative 2, right? Because negative 2 has factors of negative 1 and 2 and negative 2 and 1. And so we want to make sure we get that negative 1 out. But we can't forget this x to the third up here. So if we want to prime factor an x to the third, right? X to the third splits up into x times x times x. And so my prime factorization would be this whole big chunk. Okay, so that's factoring type 1, which again, I hope for the majority of us, like, oh yeah, I've kind of seen that before. I just needed that reminder with the variable. Okay, the next type of factoring we're going to talk about is a GCF. Now, hopefully remember that this stands for greatest common factor. We're sort of going to talk about this in two ways. We can find a greatest common factor, and we can also factor out a greatest common factor. Okay, and that just depends on how the problem is worded. So a greatest common factor, greatest means the largest. A factor is a number that will divide into something, okay, that multiple numbers share in common. So the largest number that will divide into multiple numbers evenly. Okay, so if we want to find a GCF, so maybe we have 16x to the third and 40x squared. And we want to find the GCF. So here's the thing. We're going to pretend for a minute because there are going to be some of us who look at numbers and we just see the GCF. It sort of jumps out at us. And there's going to be others of us that's a little bit more difficult to see. It doesn't matter as long as you know a way to deal with it and still get the GCF. So for just a moment, we are just going to pretend. Even if you see a larger number, just pretend with me, because there might be times that you don't see the GCF right away. And let's say we look at 16 and 40, and the largest number we think of that will go into 16, that will also go into 40 is 4. Now, if you saw something else, just ignore it for a moment. If you saw 4, perfect, you're right with me. Okay, then we're going to look at the variables, and we're going to look at ones with matching bases. So I'm going to look at the x's for right now, and we want to take the smallest exponent. Okay, so we're going to see if they both have an x. Yes, they do. And then we want the smallest exponent. Okay, so 2 is the smallest, so I'm going to divide out of 4x squared. So remember, we said when we're dividing, we're going to divide each of these individually by the 4x squared. So 16 divided by 4 is 4. 3 minus 2 is 1. 40 divided by 4 is 10. 2 minus 2 is 0, so there's no x left. Okay. Then you're going to do that process over again. So now we're going to say, what can we think of that will go into 4 and 10? Well, they're both divisible by 2. Now, as long as you took the smallest exponent up here, you should only have to worry about the variable one time. Okay, so you shouldn't have to worry about the variable again. So 4 divided by 2 is 2. 10 divided by 2 is 5. Then you'll ask yourself again, what goes into 2 that will also go into 5? And this time our answer is 1, right? Nothing, but it's truly 1. 1 will go into both of them. When you get to the largest number being 1, then you're done dividing out. And you are going to take all the places that you divided. Okay, so I divided by a 4x squared and a 2, and you are going to multiply them together. So 4 times 2 is 8, and then we have that x squared. So our GCF is 8x squared. And while you might say, I don't ever have to do that process, right? What happens if we want to find the GCF of 242, 356, and 874? Right? Sometimes as numbers get larger, this is just the process we have to do. Okay, so know that that's always there as an option to make sure we are getting that greatest common factor. Okay, so let's look at one a little bit more complex. Let's say we have 36 x to the 5th, y to the 3rd, 90 x squared y squared, and 108 y squared. And we want to find the GCF of all 3 terms. So again, right, our goal isn't necessarily to find the largest number right away. Our goal is just to find a number right away. So you're going to ask yourself, what can you think of that will divide into 36, 90, and 108? And if the largest thing that you can think of is 2 because they're all even, that's fine. Maybe you see 6. Maybe you see something else. Okay, it doesn't matter. You're just going to see what you see. Okay, then we're going to look and see if they all have the x's. So we have an x, oh, no x. If they do not all have the variable, we cannot count it as part of the GCF. So the x is not included. Then we are going to look at the y's. We have a y, and a y. They do all have the y. We are going to take the smallest exponent. So I'm going to divide out a 6y squared. So 36 divided by 6 is 6. X to the 5th, I subtract y. Okay, and then you're just going to keep going. 90 divided by 6 is 15. X squared. Those y's cancel. Let's see, 108 divided by 6 is 18, and the y squareds cancel. Then I'm going to repeat that process. What number can I think of that will go into 6, 15, and 18? Well, that's a 3. As long as I did my variable correctly the first time, I don't have to do that anymore. So 6 divided by 3 is 2. 15 divided by 3 is 5. And 18 divided by 3 gives me a 6. What will go into 2, 5, and 6? Can't think of anything, so these I'm going to multiply. So my GCF will be 18y squared. Okay, now we want to take that process and we want to then tie that into factoring out a GCF. So if we are factoring out a GCF, not only do we want to find it, but we are going to write it as an equivalent statement, an equivalent expression where the GCF is just pulled out of the different, of the terms that we were given. So let's say we are given 14a to the third plus 21a squared minus 7a. So you'll definitely notice a difference in how this is written, right? This is written like a polynomial with multiple terms being added or subtracted. This just had the terms listed with no operation, right? Here we have a trinomial. When we go to factor out a GCF, it is the exact same process as finding a GCF. We just write the answer a little bit different. Okay, so we're going to start the same. So what's a number we can think of that will go into 14, 21, and 7? Well, those are all divisible by 7. Do they all have the variable? Yes. The smallest exponent is just a to the first, or a. So 14 divided by 7 is 2. 3 minus 1 is 2. 21 divided by 7 is 3. 2 minus 1 is 1. 7 divided by 7 is a 1. And those a's cancel out. So I'm just left with a 1 here. Okay, so I'm going to ask myself again, what goes into 2, 3, and 1? Well, that's just a 1. So I know I'm done. I've found my GCF. The difference is that here, instead of just saying that the GCF is 7a, I mean the GCF is 7a, I'm going to write my answer as factors. And factors are numbers that are being multiplied together, right? Factors of 10 are 2 times 5, right? When we prime factored, we wrote those as numbers being multiplied together. That would give us 60. So here I want to write it as numbers being multiplied together. So when we have something that's more than one term, we use parentheses to show multiplication. And I'm going to put that GCF out in front. And hopefully when we look at this, we recognize, hey, this looks a whole lot like a monomial times a polynomial, where we would take this and distribute. And that's exactly the case. If we were to distribute this out, we would go right back up here to the original problem that we started with. So what we're doing is completing a loop. Last unit, we said, okay, I can take this and I can write it as a polynomial. Now I'm taking that polynomial and I'm going back to where we started in the last unit. Okay, and so this is the factored expression that's equivalent to the 14a to the third plus 21a squared minus 7a. Okay, so let's look at another one. Let's say we have 24b to the fourth c squared minus 40b squared c squared plus 56b squared c. Okay, and if I want to factor out the GCF, again, I'm going to ask myself, what will go into 24, 40, and 56? So the first thing that I see is 8. If you don't see 8, that's okay. You can divide by anything that will go into all of them, even if you only see 2. Okay, do they all have the b? Yes, they do. The smallest exponent is 2. Do they all have the c? Yes, the smallest exponent is 1, so I'm going to pull out that c. So now we'll start dividing. 24 divided by 8 is 3. And when we divide, we subtract exponents. So 4 minus 2 is 2. 2 minus 1 is 1. 40 divided by 8 is 5. 2 minus 2, those cancel. 2 minus 1 leaves me with a c. 56 divided by 8 gives me a 7. 2 minus 2 cancels. 1 minus 1 cancels, so we're just left with 7. So we'll check again. What goes into 3, 5, and 7? We can only pick 1, which means we're done. We found our GCF, and we're going to write that GCF out here in front with our remaining terms in parentheses. And this is our factored answer.